Welcome, and thank you for joining us for this webinar presentation. We are the Defense Systems Information Analysis Center, or DSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. DSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the defense systems community. As such, our organization supports those working in the defense systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the defense systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD defense systems research.
Well, good morning, afternoon, evening to everyone joining us. Thanks for joining so far. I hope you were able to enjoy that little DSIAC or IAC commercial there. We're bringing up the slides here and we'll be able to start the presentation in just a moment. But before we do that, I wanted to give a quick overview of the AnyMeeting platform and the timeline of the webinar and how we're going to handle this. My name is Brian Benish with the Information Analysis Centers. And if you are joining us through the AnyMeeting web platform, a couple things I wanted to draw your attention to. First and most importantly is the audience question icon. It should be at the top middle of your screen, the little chat icon. At any time during the presentation, I would encourage you to click that and submit your question. What we're going to do is have Eric give the presentation, and then at the end, we'll do a little Q&A portion. So at any time during the presentation, if you have a question, just go ahead and get it in queue for that final Q&A portion. Secondly, this presentation is being delivered live, but we are recording it, and we'll make that available after the fact. So if you have any technical issues, just rest assured that we do have the presentation recorded. But then if you do have any other technical issues along the way and you want to still join in, you can join in by phone. There's a phone number associated with this, and you can download the slides from our webpage. If you went to DSIAC.org, went to the webinars and found this webinar's webpage, there's a link to download the slides and you can follow along from there. And so I think that covers the basis for the top level logistics of the webinar. And so at this time, without much further ado, I'm going to go ahead and hand the mic, so to speak, over to Eric for the presentation, and I will chime back in at the end unless there's any other issues along the way. So Eric, the floor is yours.
All right. Good morning, everyone, or afternoon, wherever you might be. As I stated, I'm Eric Harkleroad. I am a modeling and simulation technical specialist at the DEVCOM Analysis Center. If you're unfamiliar with the DEVCOM Analysis Center, we are under the U.S. Army Combat Capabilities Development Command, or DEVCOM, which is part of the Army Futures Command that was recently stood up a few years back. If you are familiar with AMSA, the Army Material Systems Analysis Activity, or the Army Research Lab Survivability Lethality Analysis Directorate, or parts of the Human Systems Integration. Those 3 organizations combined and formed the DEVCOM Analysis Center when DEVCOM and DAC were created. So kind of more background on what DAC is. DAC informs Army modernization and readiness decisions by conducting thorough analyses enabled by tool development and data curation. Some of our other core competencies are data science, operations research, mission effectiveness analysis, integrated material performance, cyber resilience, human engineering performance, and EW threat defense. So mostly what we're going to be talking about is modeling and simulation, which kind of falls under our integrated material performance, and the analysis we do typically falls under the mission effectiveness analysis area. So I'm in the C4ISR division in the ISR branch, the Intelligence, Surveillance, Reconnaissance branch. I'm going to be talking about our modeling and simulation capability that's called TIPS, the Tactical ISR Performance Suite. That is a module within a larger modeling and simulation framework that we call FRACTALS, which is a framework for capability-based tactical analysis libraries and simulations. So getting started, so if anyone had ever heard of a different simulation called FOCUS, which was the fusion-oriented C4ISR utility simulation, fractals and TIPS kind of together are essentially a newer version of FOCUS. I know we've gotten several questions from that people had talked to DSIAC in the past. We've had some articles that were published. Most of them, or I think all of them, had to do with FOCUS, but that's more of our legacy simulation. And now we are working with fractals and TIPS. So they are the same thing. This is just kind of our newer implementation, and we changed the name. So TIPS, the Tactical ISR Performance Suite, is a modular code library that houses our sensor performance and intelligence process capabilities, which is really just our algorithms and methodologies for sensors and intelligence processes. So what we've done with TIPS is, or the way that it works is, we have decomposed what a typical sensor will be made up of. So a field of view, what is the limits of what this sensor can see. Performance models, which is really just things like calculating the probability of detection or a signal to noise ratio, whatever the metric is that would tell you how well the sensor is performing. And then a measurement model, which is also once you have a detection, what is that detection or acquisition telling you about the object that you're detecting? And for the most part, that's where is something located, and whether that's some Cartesian coordinate, or are you only getting range from where you are, or an azimuth angle or an elevation angle, things like that. So really, we're grouping all those three together to form what the sensor is, or what the sensor is capable of doing. We also have information processing models within TIPS, so things like data fusion, direction finding, and other processing, exploitation, dissemination processes, or PED. All of these things are kind of custom resolution. So you can have performance models that are as simple as a probability of detection versus range, or you can have something very complicated that's more of a physics-based, lots of inputs that go into calculating a signal-to-noise ratio and other effects that might be affecting that with the environment, all dynamic within a simulation. Those also go along with custom resolution behaviors and processes. So how are you searching and acquiring different targets? How are you being tasked with a sensor? If the sensor has multiple modes, how are those modes used, or when are they used? How do you switch from one mode to another mode? All those things are configurable within the simulation using the kind of building blocks that are put together within TIPS. So the kind of already mentioned the last one, the varying fidelity performance. The different sensor modules that we play, for the most part, we have EOIR, or full motion video, and radar capabilities that are, I would say, are the most complete performance models and things like that we play. We can also play SIGINT, which is ELINT and COMMENT, and other sensor modalities, as well, things like synthetic aperture radars, or maybe acoustic type sensors that are within there. And really anything that you could put in there with a simple curve, you'd be able to play. Just the ones that have the most complete kind of physics-based models are the EOIR, radar, and SIGINT. So while I'm talking about the, having these custom resolution behaviors and processes and all the different pieces of the sensor and all that, so those are really what are within the TIPS module. So that's kind of broken up into the different little pieces of the sensor and the behaviors and the processes, and all of those things come together when you put them within our FRACTALS modeling and simulation framework. So FRACTALS is really kind of agnostic to any of the capabilities or the algorithms and methodologies. It's really just a framework for bringing those things together and actually playing them in a tactical level simulation. So again, this is a DAC developed composable component level framework for enabling rapid development of tactical level event-driven simulations to assess the performance and impact of complex integrated systems. So essentially what that means is you can piece together the behaviors, when you're doing the search and acquisition, when you're doing dynamic tasking, you're playing the entity level objects, or even down to subsystems and different modes of sensors in a 3D environment, and you're able to say where things are moving, where you're doing your search, when things are picked up, having environmental effects, and it will process all that information with stochastic random numbers and give you the results of what's occurring in your vignette. FRACTALS also provides some visualization tools for seeing how a sensor search pattern would look, as well as coverage on specific terrains. So it also provides the user interface for doing that. You can also do just straight item level data or sensitivity analysis on the sensor performance models. So if you're really just interested in seeing how does the probability of detection change for this sensor versus range, you can create charts and everything that displays that type of information straight from FRACTALS. We've also been working with kind of an external application called the multi-domain sensing architecture, trying to get features of TIPS within that, so we would be able to play them, outside of DAC, using our methodologies and algorithms, beyond just within the analysis center. Okay, so on the next slide, I'm going to go into some of the things, kind of explaining how FRACTALS works, and then later I'll be going more into how we do things within TIPS. So the system architecture in FRACTALS, it provides an API, application programming interface, for building vignette-based event-driven simulations. And essentially, when you open up FRACTALS, the application, you're kind of starting with a blank slate. You select your terrain space, which can be a simple flat terrain, or it can be, we can play DTED level 1 and 2 data, which is, for bigger areas, as DTED level 1 is approximately 100 meter spacing, level 2 is 30 meter spacing. We can also play LiDAR data, which is typically around 1 meter spacing. So we use that more for urban areas where the terrain changes very abruptly, and you would want that kind of resolution. So when you bring in that terrain, you start really with nothing. You have your two sides, blue, red. You can add to that as well and have multiple sides beyond those, but those are kind of the default. And you have to create each of your objects that you want to play in your scenario or vignette, and that can be as simple or complicated as you want it to be with the amount of time that you would put into building that. So to do that, you are creating entities, which are really just empty shells of some object that you're naming. That can be a system or component, and you would attach, sorry, just went forward. You can attach sub-entities to that, capabilities and properties. A capability are the things that are within, say, the TIPS module, where it's data, algorithms, behaviors for performing a task. So the tips module would give you a sensing behavior, or the a data fusion behavior, or capability. We'd also have things for moving or communicating information, things along those lines. And then finally, properties, which are descriptive data, tags, or state that's attached to the entities or capabilities. Things like position, velocity, a signature, things that you could change or going to be changing, that really just describe the state of the object. And that can be attached to either, an entity, a sub-entity, or, a capability itself. So it says developers implement capability modules and properties to build the functionality for a simulation configuration. So currently within DAC, fractals and tips are developed by myself and Javier Gastido, who's also in the ISR branch. We are looking to expand into different areas. We have done some things with power and energy, and we're also doing some things with active protection systems. But for the most part, we've been still doing the development. The plan is to get additional developers, hopefully within other areas of the organization, to be able to build additional capability modules. Because our expertise is in ISR, we would prefer people that have the expertise in that area to develop different capability modules and properties for the areas that they're experts in. So kind of these pictures down here at the bottom show the user interface of fractals. This is showing the force structure, which, it's probably really hard to see, but there are several entities here with some sub-entities, and then adding capabilities onto here. And here's a list of the current capabilities you can choose from. And then on this one, you're adding a property for saying, what does this thing look like? What is its size? Where is it located? Sort of thing for a property. So the next part of fractals is really the driver for, how your scenario works, or while you're running it, is the process flow. So this allows users to construct dynamic execution paths in the simulation using visual coding. So essentially, there is a list of blocks that you can choose from. These are things that will be added to over time. And as I said before, we're looking for additional developers to add capabilities and processes and behaviors into this, so you can get more and more functionality over time. But you create and connect these process blocks through these kind of trees to develop how your scenario is going to play out. And those blocks can be something very simple, such as just some condition of randomly choosing a path, or it can be a very complex mission of describing everything that say a radar is going to do as it searches and detects targets. As those behaviors or missions execute, typically they're going to fire off events. So there is an event block that it can listen for certain events. Say on a sensor capability, one of the events is I made a detection. So when that occurs, that block is going to be listening for that, and then it will pass execution to additional blocks based upon the information that's on in that detection event. So you piece all these together with different conditions, different events, and then the behaviors and missions, which can also be put inside groups, where you can have things that are related to each other within the groups. And if that group ends, other things within the group would also end with it. So you can piece all these together. And again, as I said, it can be as complicated or as simple as your vignette or scenario needs to be. So at the bottom, it also says connections between blocks allow data transformations in order to pair block outputs to block inputs that may be independently developed and not directly integrated. So something I really haven't mentioned about fractals is how each of the modules are really completely separated and independent of each other. Fractals itself does not actually know about the modules, so it has no idea that TIPS exists. When it executes, it brings in or imports in, similar to, say, a plugin, the different modules that have these capabilities and the behaviors within them. And it brings them together within the user interface. So as the user selects those things, it creates the instances of them in the those independent capability modules, and that's how everything brings together or comes together to form your vignette. So when you have certain behaviors, if those have an output, they might not line up perfectly with the type of data that, say, a different behavior is expecting it to be input. But for the most part, we have common kind of basic building block things like the entities or capability or locations and things like that you may have to transform that data to get to the expected input of a different behavior. So the process flow has all these things built into it to allow interactions between all these independent capability modules that already exist or will exist in the future. So to sum it up, Fractals, extendable framework to build mission-based tactical level simulations, developing capabilities using Fractals API are automatically integrated into the user interface for use in scenarios. So that's kind of how I was saying that things are, if you're using the Fractals API to build your capabilities and behaviors, those would be exported from your module and be automatically imported within Fractals within the user interface to be selected for while you're creating your vignette scenario. So the diagram in the middle kind of explains everything, kind of the loop of what happens when you execute. So you have your entities that have capabilities and properties. Those capabilities are what perform the behaviors and processes, which are all linked within that process flow. As those execute, they raise events. Those events would then change the state of your entities and also affect the sequence of behaviors and processes. And all that would just loop together to form your mission-based simulation. And within there, you have different sim options and the environment. And typically your events are what are driving your output data of what occurred that you're interested in for your analysis that you're doing. So now getting more into what we do within TIPS, so more of an ISR focus, is sensor system modeling. So the sensor systems are modeled as a group of sensing capabilities. So say you have an EOIR camera and it has 5 different field of view levels. Each one of those field of view levels has a different performance model, has a different field of view. So each one is kind of treated as its own capability. If you put those, say, 5 field of view sensor capabilities within the same entity, it's treated as a system that all of those things work together. So it wouldn't allow you to be using multiple modes at the exact same time. You would have to switch which one is active within that entity, because you can't be looking at 2 field of views at the same time. So you use behaviors to control the target acquisition timeline of the system, given a searchable object and location, a search pattern or sequence, and an optional type of target that you're looking for. Maybe it's a vehicle or aircraft or person. The sensor observation processor capabilities can handle complex logic for processing acquisition events. So something specific for, say, a radar, you might want to have something so tracking what you've already detected and automatically revisiting that track with the radar. So kind of breaking out of just the search pattern, you need to go back and revisit something that was already detected that's not, part of the search pattern at first. So those sort of behaviors you can write to handle the complex logic that's specific for how a certain sensor works. So that's where it comes in of, as different sensors have different type of capability for what or how they work, we would be adding additional types of behaviors to handle that. We're also working toward breaking some of that stuff down into more primitive behaviors. So hopefully in the future, we would be able to kind of use more of the blocks within the user interface to change around how it works, and be able to handle that sort of thing without changes to code. So at the bottom, it's kind of a typical target acquisition task and how that would work. So if you have multiple sensor field of user modes, you would have something that's selecting which is the best sensor for the task that it's given, and then jumping into actually doing the collection behavior, which would start your within that collection behavior. That kind of jumps down to the bottom image where it's going through the processing of updating your field of view to possibly a new location, checking for what's within that field of view as far as signatures of targets, doing checks on those and whether you can detect them. Do you have line of sight? Is say the frequency within the range of the sensor to be picked up, running the performance algorithm, whatever that might be, getting the output from that performance metric, assessing that against whether it's just a random draw or some threshold that you need to reach. That would all go into filtering the results, and then you're reporting your acquisition, which would potentially raise events for a detection being made, or maybe there's nothing there. So as that happens, you're jumping back up to the top diagram. Say a detection event did occur, you can then process that information, and maybe there is a different behavior you need to do, say zooming in on that object to look with a higher resolution mode of a sensor, or maybe a completely different sensor. So that's kind of how it would work with a sensor system within that process flow. That's essentially what TIPS is capable of doing with these building blocks within, and having different resolution tasks and behaviors for defining how something works, hopefully handling complex logic for different types of sensors. So again, along the same line, so this is kind of assuming, okay, you've made detections or several detections. What do you do with that information? So that gets into the PED and data fusion modeling. So we take, you detect in the diagram at the bottom, you have your detection event that's raised, something that would be reported to some other unit that would process that detection, maybe do some filtering on that of what you're interested in, forward that to a different PED unit that can potentially have capabilities for doing fusion on that information. So if you have multiple measurements that are associated with the same target, would you fuse that together with, say, something like a Kalman filter that we can play within fractals and TIPS to get a better measurement of where something is located, and then pushing that back to, say, a mission command type capability that processes that information and can make decisions on, do we need to retask a sensor system to do something with that information. So this is a really, really simple case here, but you could have different behaviors and links between your process flow for PED to do different tasks of dynamically collecting information, processing it, fusing it, disseminate it to different areas, and retasking sensor systems to deal with that data. So some sample analyses to be done in the ISR area using TIPS and fractals. We've done a lot of aerial ISR imaging analysis. So things like looking at the effectiveness of having multiple full motion video cameras versus just having a single full motion video capability in tracking and search detection identification over a designated time period. We've done the impact of static versus dynamic TTPs in tracking. What that means is essentially, are you staying in the same place tracking something versus following it? That would be the dynamic part. The impact of terrain artifacts on detection and tracking. So that could be things, the actual line of sight of the terrain, or also other environmental factors. So you can play things like fog or rain and how that impacts the sensor performance. Different TTPs for an aircraft would be hovering versus do you have fixed wing where you have to do loitering, and how does that affect the performance in, say, an urban vignette where you might have line of sight problems if you're not able to get more over top of where something is located. And then also we've looked at things like having a fixed sensor that, it is fixed just with wherever the aircraft is, versus having a gimbal where you can look essentially, much wider range of where that is able to look down on, say, on an aircraft within urban operations. And the bottom, excuse me, doing the target location error sensitivity analysis. So we've done things with SIGINT and different types of methodologies, say like an angle of arrival methodology, and how that's affected by the detections you're getting with a SIGINT system over time. And looking at how long does it, when you're varying the number of lines of bearing and where those lines of bearing are coming from, how does that affect your target location error? And we doing a sensitivity analysis on having multiple flight path lengths. What was your standoff? What is your altitude? How often is the emitter actually transmitting? Those sorts of things. We've also looked at radar point of origin type target location error. So as a radar is tracking a munition over time, are you able to back calculate where it came from? So we have some methodology in there that a polynomial kind of fit back to a point of origin, and we also have tried a reverse Kalman filter for that point of origin. So another thing that I mentioned kind of at the start was different visualizations within FRACTALS that are still using tips, but just not within really a scenario, but more of just a more simple UI, this for visualizing coverage or search patterns of the sensors. So we have what we call a dynamic OV1 visualization and coverage analysis module that allows you to look at locations, different terrains, different sensors with different fields of view, what their performance would be at certain standoffs or altitudes, and you'd be able to visualize what that looks like, how much coverage you're actually getting on a terrain very quickly. We say the impact of that is giving analysts a real-time visualization tool to brief senior leaders. That's more impactful than just having one of those charts that has a bunch of icons that don't really tell you what it really looks like, but just saying, oh, I can see over there, sort of thing. And then the pictures along the bottom are showing you, given some flight path, what type of line of sight would you have on a very specific terrain over time, and giving you a kind of high level look at what area you're able to cover with a certain flight path. So some more current or recent and future development analysis. So as I mentioned before, we were doing some work with power and energy. We worked on different energy consumption rates for UAS, looking at more of a battery operated UAS. So it had to have to return and recharge before they're able to go back out. Looking at sensitivity of number of consumers or provider stations, varying numbers of small UAS flying different coverage routes, and also having maybe the impact of recharging from a standoff versus coming all the way back to an area to recharge. I also mentioned we've been working with active protection systems, so we're looking to do some end-to-end modeling of apps hard kill solutions. So we're adding in things such as playing ballistic trajectories of threats, making a lot of improvements to our radar measurements and tracking systems, the performance algorithms, and dealing with things such as multipath within the radar measurements, modeling fire control systems and calculating point of intercepts, things like that, playing launchers, and the countermeasure fly out and result, and how you might alter the countermeasure as it's flying out to hit with new information. And we've also recently added another kind of UI module for doing space ISR analysis, so that similar to that dynamic OV1, it has a full globe visualization instead of a very specific area with the terrain. You're able to visualize satellite movement and space-based sensor coverage and performance looking at that. So finally, just to wrap up Fractals and tips. So Fractals enables rapid development of multifunction integrated systems for quick turn performance analysis. I like to think of Fractals as it's definitely not it's not a force on force simulation, but if you are looking for analysis of a system doing a task that's complicated and the timeline is possibly very short, but a lot of things are interacting with each other during that timeline, then Fractals gives you the resolution and fidelity to be able to play those things and see differences where, in things that are more force on force, you might not be able to see the difference on how something works with the data that's in those. So kind of looking at that, the apps work that we're doing, being able to look at very specific radar measurements and how those affect the point of intercept that you're going to get based upon the terrain and things like multipath, and what your success rate is going to look like on, based upon different radar performance and what you're able to see in the timeline that's super short. Fractals is very good at handling that type of analysis for that type of system. And we're looking to expand beyond ISR into other areas, ballistics and other types of areas that DAC also has subject matter expertise in. And then tips, so that, like I said, that has our validated ISR models for reuse, provides methodologies, simulate end-to-end intelligence process. So our code library is available for external applications. You can do that for just doing item level performance, data generation for different types of sensors, EOIR, radar, SIGINT. And when combined with Fractals, it gives greater flexibility in creating complex ISR systems and behaviors without code changes. And we're kind of adding to that over time to make it even more flexible. So I think that is the last slide. I guess we're going to open up to questions.
Yeah, absolutely. Thanks, Eric. It was a great presentation, and you did a very good job summarizing everything. And we did get a question that came in, so I'm going to go ahead and move over to the Q&A portion. And as I do this, I will just remind everybody, at the top middle of your screen, there should be a little chat icon where you can click it to submit a question, and you can submit your question. And I will pop it up on the screen, throw it over to Eric, and see how he can respond to it. So first one that came in, Eric asks, can you describe how Fractals and TIPS are different than several of the other commercial systems like ANSYS, AGIs, and STK, or AGI's STK?
I'm not familiar with ANSYS, and I'm not that familiar with STK, other than I know that it does a lot of satellite space type work. I mean, the biggest difference is just our use case. So, internally to DAC, we want to be able to put in, our own methodology for the sensors we're interested in, and make sure we're able to play things and know how it's being played, since we're doing the analysis on it and making comparisons between systems. So I'm sure there's tons of overlap with lots of other simulations. It really boils down to having the control of knowing what's in the simulation and having control over making changes to that and playing the systems the way that we want to. Hopefully that answers your question.
I guess kind of maybe a follow-up for me on that. Have you, I mean, I guess you haven't heard of these in particular, but have you done any kind of comparisons between the assessment process, kind of the unique secret sauce that's in your models versus some of the other ones that are available, just to see how they play out? Are they dramatically different, and how to evaluate that assessment process methodology you've got built in?
Well, honestly, I don't know how most other commercial software play their sensors.
Mm-hmm.
I'm not sure I can really answer that. I mean, Fractals and before that, Focus has been around for 17 years. So
Right.
back then there was, before we created this, there was, looking at these sort of things and what was available. And I know that, just because we're a government organization, there's a lot of licensing fees and things like that where you might not want to be dependent upon a commercial system long term for to be able to do the analysis that you need to do. So, back then the decision was made, we're going to make our own in-house simulation, and it has evolved over time. So I'm sure there are, I know there's other options out there, but with internal to DAC and our mission, it makes sense to have this capability.
Gotcha. And I apologize if you already said this, but has Fractals been VDNA, kind of an official accreditation of the Army?
So we have done V&V of different aspects of Fractals. So as I was kind of saying, the different capability modules really are almost like a standalone thing. Right. So it's not when you create a vignette or your scenario, you're essentially creating the simulation at that point. Fractals itself is really just the framework for building a simulation. So each time that you're using it is really when you would want to do some aspects of the validation and the crediting it that it makes sense for your application. But the internal modules and the methodologies say, how we do the performance of an EOIR camera. Mm-hmm. Those sorts of things have been verified and validated.
Gotcha. Yeah, and that's the real important part. Okay.
Yeah.
All right. Good. Well, I appreciate the response to that question. And we move on to the next one. Next question, kind of somewhat similar question about comparison. How does this relate or compare to ISR sensor methodology and tools like OneSAF or AFSIM? How about the level of fidelity?
So at least for, I'm pretty sure for something like OneSAF, I could be completely wrong. I'm not an expert on OneSAF, but I believe that their timing aspects, maybe the lowest you can go is 1 second. In Fractals, we don't really have a limit, or it's in microseconds. So when I was talking about our apps project, we're looking at moving the radar field of view in microseconds. So that level of fidelity is much higher than what you would see in something like OneSAF. I don't know much about AFSIM. I don't know whether you can change that or go that low in that. I don't know.
Gotcha. Okay. Fair enough. All right. We go to the next question here. Tried to do a little pre-read of it. I think I'll have to do some interpretation here, so bear with me. But on the face of it, the question says that to accept the code and scripts that you're willing to share for us to implement fractals in our work, what software licenses for tools or what capabilities would we have to implement as a baseline to replicate your capability in our efforts or enterprises? So maybe the heart of the question is, for somebody else who wants to use fractals for their work, are they going to just sort of have to reach out to you and let you all kind of run it, or is there some sort of opportunity for folks to license it? And if so, what will they need to be able to run it sort of on their
own? So that question is a little bit up in the air. We don't have a really clear answer on whether we're able to just give fractals out to external organizations. In the past, we have given, I was talking about our focus simulation, we have given executable versions of that to other government organizations, or if you're a contractor that's working on a contract with a government organization, we have done that. So I would say at this point, it would probably be just a case-by-case basis coming to us.
Okay.
And whether we could make something work. Kind of as I said, right now we're really in the phase of getting additional kind of expertise within our organization to improve it. But I would say one of the goals or vision is to make this available for external organizations as well.
Gotcha. All right. Well, I would then recommend Alan reaching out to you all for potential kind of collaboration there and use of fractals. He did comment and just say his group is a government organization, I think, so he can with the Army in particular, so he can maybe you guys have a better way of working together then. Okay. Next question, maybe another one from Alan here, is about using fractals. Have you ever implemented fractals for modeling and simulation of manufacturing lines to model production for fielding new systems, or modeling maintenance and sustainment piece and parts?
So I definitely have not done a manufacturing line. Yeah. So as I kind of covered, it's mostly, at this point, it's mostly for sensors,
right?
On doing different types of missions or in the field. I would guess that if we created different capabilities and behaviors and things like that to model things that are on manufacturing lines, the framework itself would be able to handle that. It's just not things that we currently have in there or are the focus of what we would use it for currently. Not that it can't happen, but that would just be something new.
Right. Okay, good, thanks. That's the end of the questions so far, but I might kind of want to ask one more, if you don't mind, which is about use of the model. Obviously, you're presenting this in an unclassified forum here, but I suspect that during some scenarios you will produce classified data. Is this to be run on a classified network and system, or is this strictly kind of an unclassified setup right now?
So we run fractals on our on our secret network. It is just a standalone application that that we're running. So it's not like we're running anything in the cloud or actually on the network. It's really just on a classified machine.
Okay. Yeah, that's kind of where I was going to go with it. Is asking about how it's integrated, whether it's on the cloud or it's just standalone. But you answered that. Okay. Good. All right. I think that's about it, unless anyone has any follow-up questions. We just did get one that came in, so just bear with me. I'll add this to the queue. All right. So next question that just came in here says, I believe the model like OneSAF has a system change request, SCR cycle or process. Does how does the OneSAF SDR process compare to implementing a change in Fractal? So do you guys have an SDR submission portal or process or anything like that set up yet?
So we don't really have that set up. We're, as I said, the current developers are myself and Javier Gastido. So when we have people, we've been working with other pieces of DAC, they're coming directly to us. You're working with the developers directly. So when you want something done, or we have a project we want to work on, through some customer, you would be working with us directly, and there, we don't have to go through maybe a drawn out change process. It's typically, very quickly that we can just jump right in and start working on those changes. Once that's designed and we have the requirements and things like that. So I would say that's another big difference between us and a big program like OneSAF. We're not limited by potentially long drawn out processes for making change and what we can work on. If we feel that it's something we need to do, then it's almost immediate if we have the time to make the change for the analysis that needs to be done.
Gotcha. Well, I'll put in a quick plug offer here that this is one area that DSIAC we can help with. We could help with some of that administrative, maybe interference between receiving setting up an SDR site for user requests before so it doesn't overwhelm the small group that you guys have. We can kind of help do that on your behalf, and maybe even help with some of the administrative of distribution and all. So we can talk offline about that, but I'll just throw that out there as an offer. All right.
Yep. Thank you.
Okay. Well, unless there's any other questions, I think we're reaching pretty much the end of the hour here anyway. So I'll go ahead and wrap it up here, and just thank you, Eric, for your time, and Javier for putting this presentation together. And I guess, as you mentioned, if anyone has any questions, they could follow up with you, and we can point them in your direction. So thanks again. Appreciate the presentation, Eric.
Yep. Thank you. Thank you all for attending.
All right. Take care.